Okay, can you guys hear me fine? That looks good. Okay. Hi everyone, welcome to the last talk of the day. I'm Aroj George. I'm a lead consultant developer here in ThoughtWorks. All right, and I am been a programmer most of my life, but I love the DevOps field and I'm quite passionate about continuous delivery. And that's why I was quite happy when last year I had the chance to drive the continuous delivery setup for my client, for our project. And so this talk is going to be about how we went about setting up the continuous delivery infrastructure, what tools we used and how we went about doing it. Okay, so let's get started. Our choice of tools for this project was ThoughtWorks Go and Chef configuration management framework. How many of you have heard of these tools? Right, so quite a few of them, right? So ThoughtWorks Go is a great tool for modeling CD pipelines, continuous delivery pipelines. And Chef is the configuration management framework we used for provisioning our environments, right? So at the same time, this talk is not so much about the tools themselves. I mean, you could have used some other tools like Jenkins, or maybe you are a Puppet person or Ansible person. I mean, in this case, we happen to use these two tools, but I hope the concepts are more applicable in general, right? So we've been talking about continuous delivery today, and if you just think in nutshell, what is continuous delivery, right? It's just a matter of, it's basically going beyond continuous integration, right? You not only just talking about continuous integration, but you want to regularly deploy your application to your QAs for validation, to your business for validation, and for potential release, right? So it's continuously delivering, regularly delivering your application to your stakeholders, right? But at the heart of the continuous delivery is a CD pipeline, right? And what is the CD pipeline, right? I think it's basically trying to ask just this one single question: Is this commit or is this change good enough to go live, right? And how do you answer that question, right? So basically, you pass your commit through a series of stages. Each stage trying to validate that, okay, are you worth it? Are you good enough to go live, right? And if your commit or your build actually passes through all the stages, then it's good. It's good enough to go live, right? And this pipeline is basically fully automated verification of your commits, right? So here's an example. Is it clear, visible clearly, right? So you got the various stages. It starts from a commit made by a developer, right? Build successful, continuous integration, test environment, pre-production environment, and finally to the production environment, right? And if you look at the stages, what you would say is that the stages towards so these are the various stages in a pipeline, right? And if you look at the timeline on top, it says fast feedback on left and increased confidence for production, right? So what does it indicate? It indicates that the stages towards the left, right? There are stages which give you the fastest feedback in the quickest amount of time, right? And as you go towards the right, are the stages which will take more time, but they'll do more thorough probing of your commit, of your build, right? So that's how you typically model a continuous delivery pipeline, right? With the key idea being that you want to fail fast, you want to get the feedback the fastest, right? But at the same time, you want to be really confident before you actually release to production. Cool. Now, with respect to the CD pipelines, I can talk about two things. One is build pipelines and deployment pipelines, right? Now, what is a build pipeline? Build pipeline is what you must have seen as part of a CI, right? Whether your commit, is it good, right? Has it passed all the tests? Has it compiled, right? And it's triggered for every commit, right? Whereas deployment pipeline basically takes it further, right? So you have so what's the output of a build pipeline? It's probably going to be a build artifact, a jar file or an RPM, right? And you want to now push it to your environments. You would start off with your QA environment and then your staging and finally to production, right? So a deployment pipeline is what is going to automate the promotion of your build artifacts across environments. Cool. Now with those concepts in place, let's talk about a few of the Go domain model concepts. So Go was basically designed with this concept of pipelines, right? It was designed from ground up to support pipelines. So what is the pipeline for Go, right? So pipeline for Go is basically a sequence of stages, right? and each stage runs one after the other. A stage can be a manual stage or an automated stage, right? So for example, in this case, if you see there's one pipeline, and there are 3 stages here. Stage 1 is compile and unit test stage. Stage 2 is functional test stage, and the third stage is UAT stage, right? So your build, it starts off with this, with the check-in triggering the pipeline, and the first stage runs. The first stage has 2 jobs, a unit test job and a MR job, right? It's probably a code coverage or a code lint job, right? So jobs, actually, a stage is made up of jobs, and jobs can actually run in parallel, right? For example, one thing could be that, let's say you're, in case of functional testing job, right? Functional testing stage. Let's say you want to run functional tests, but you want to do it for Windows as well as Linux. Now you don't want to really run them in sequence because that's going to take a lot of time. You'll first run Windows tests and then Linux tests. This is something that can be easily run in parallel, right? So you see there are 2 jobs. First is the Windows functional test and Linux functional test, right? So essentially that's how a Go pipeline is structured. To repeat, you got a pipeline which is a sequence of stages. They run one after the other in sequence. A stage is made up of jobs which can run in parallel, all right? And these stages can be manual or automated. What do I mean by that, right? Let's say the first stage finishes, and let's say the first stage actually fails. Then you don't want to run the remaining stages because there's no point in running the remaining stages. You already have a red build, right? But if the first stage goes green, then the second stage is automatically executed, and so on, so the third stage. But you could also have a manual stage where, let's say the second stage is manual, so which means that even though the first stage goes green, the second stage won't be executed till you actually go and do a manual trigger, right? So I'll come back to it later on why you would need a manual trigger. Typically, you'll always have automated stages, one after the other. They'll always run if the previous stage has been green, right? So that's it about the Go pipeline. Any questions at this point in time about the structure of stages and jobs and pipeline? Okay, yeah.
You talked about different pipelines.
Right.
So do those pipelines work in parallel or can they overlap or do they have to also work on a stage basis?
So I talked about build pipeline and deployment pipeline, okay? And I'll explain more about it, how they work together. This, what you see, is a specific Go pipeline instance. This is how we configure a pipeline in Go. You can just create new pipeline, and then you can create new stages, and you can create jobs in them. So maybe I'll come back to later, and I think it'll get answered. Yeah.
I have a question regarding this manual
Stage, yeah.
So suppose my first stage failed.
Yes.
And second stage is manual.
Yes.
So in manual, maybe you might have something like notification where the person who is doing the manual job will get a notification. So even in the case of failure, do they get a notification? And next stage is manual.
I think you can configure it basically, that do you really want to go to the second stage even if the first stage fails. Okay. So that's the choice in Go configuration.
In a stage we can configure it? Or?
Every stage you can configure, but by default it's automated and it will go to the next stage only if the previous stage is green. Yeah. Sure.
In reality, when
Yeah.
you push up updates or upgrade for applications, normally applications are built up of multiple artifacts.
Yes, yes.
In reality, applications are complex.
Exactly, yeah. There are multiple components. Yeah.
In certain cases, these components are being built by someone else from the core application team. There could be some platform.
Right.
And these pieces have to come together.
Right. Yeah.
And so what we have seen, that in whatever I have worked so far, when change goes through, it's
Okay.
only 1 or 2 of the artifacts.
Right.
Out of the 10 artifacts that are within the
Fair. Yeah.
change.
Right.
So how do you control that piece here and that only those
Right.
getting pass through?
Yeah, that's a good question. I'll be coming to that because our application has something similar. So I'll come to that. So, but at this point in time, Go concept's clear. Shall I move on? All right, cool. So another concept to talk about is traceability. What is traceability? Traceability is basically tracing the flow of each and every commit through your build and deployment pipelines, right? If I look at a commit, I should be able to trace when did this commit pass which stage in which build pipeline, when was this commit deployed to which environment through which deployment pipeline, right? When was it deployed to UAT, when was it deployed to production. I have the full traceability, the history in Go, in the Go dashboard, and anybody can take a look at it. You don't have to be a developer to take a look at it. It's a web dashboard. The whole history is there. Similarly, the reverse traceability. If I look at a deployment, I should be able to go back and trace it to which commit actually triggered this deployment, right? So the traceability is enabled through something called as pipeline labels. I'm not sure if you can see this, but I'll try to read it out. So what you see here are different pipelines. We've got inventory pipeline, catalog, and website. This is an example. And they are all feeding into an acceptance test pipeline, which is basically testing the integration of all of them together, right? And if you probably cannot make out, but what's happening here is the labels. There's a label here called catalog -110 something. Similar labels for each of the pipeline. And what you see in the acceptance test is the combination of all the labels, right? So by looking at these labels, which are promoted across pipelines, you can actually get full traceability of what was deployed to what environment, and you can reverse trace to. So if you look at this, right, you can reverse trace the production. So once it's passed acceptance test, it's gone to production with the same label combination, right? And you can reverse trace back to the commits which actually triggered the final deployment to production. So that is about Go concepts, just few of that. Then I'll talk about a little bit about Chef, a very brief about Chef. So Chef is basically based on this infrastructure as code concept, right? I mean, at its very simplest, what does it really mean? It really means that, traditionally we've been used to, let's say somebody just goes and makes a change in environment, and you don't even realize when you did a change, what change was done. It's all manual, right? And all the environments, when you're doing changes to environments manually, it means the environments could diverge over time, right? And you lose track of it. Now, instead of that, what if you could actually script your environments? And what if you could check in the scripts into source control? And what if every change that you make to an environment is actually through the script and is actually checked into source control, right? So suddenly you have version control to your environment. I mean, that's the essential fundamental concept behind infrastructure code. And Chef is a framework which basically allows us to do that, right? So it allows us to create these automation scripts which can provision environments and basically version control our environment. Cool. Show you a small snippet of Chef. The Chef calls its scripts as recipes, which is a sequence of declarations which declare the final state the application should, or rather the server or the environment should go to. So what you see here is a declaration which says package nginx. Nginx is a web server. And then you have a declaration which says service nginx. It says that service should be started. And then you have a template which defines the configuration for nginx, right? Now what will be interesting over here is that when you look at the script or recipe, you cannot make out what OS operating system this is meant to run on, right? Because Chef actually provides a nice framework abstraction over your base level OS package management systems. So for example, when you say package of nginx, right, what it actually translates down to is, let's say if you're on Linux, let's say if you're on Red Hat, it will use yum behind the scenes to install nginx. If you're on Ubuntu, it will use apt-get to install nginx. So you get this nice abstraction where you don't have to worry about what are the base operating system dependencies. You just write your code in Chef, and you declare the state, and Chef takes care of everything else. An example of how you can templatize configuration in Chef. So this is a template file, and you can see we have an if condition in the template file, which basically says that, okay, if I need to do basic authentication, then do so and so, else so and so. And these are variables. These variables can be configured per environment or per node or however you want it to, right? So that gives you the power of basically dynamic scripts in your environment. So some environments might have basic authentication enabled, let's say a production environment perhaps, or not a production, staging environment perhaps, but some environments may not, right? So these are two interesting things about Chef. Yeah, go ahead.
It's also a recipe file.
This is actually part, okay. So a Chef, a recipe is a single file which has a list of declarations. Chef can have a collection of recipes, let's say collection of recipes for installing nginx. And the collection of recipes together is called a cookbook, right? So Chef has got his whole kitchen theme going on where you've got recipes and cookbooks and all that, right? So this is actually a template file. It is part of the cookbook, but not a recipe. It's just a static file which can be evaluated at runtime. Cool. And all of this is actually, if you see, look at it, it's all Ruby code. You can actually write any piece of code in this, any valid Ruby code basically in this. So moving on to our specific project. Um, so we were actually making so our client actually had this global marketing site, and they had a different site for every country. And they were finding it hard to maintain all these different sites for every country, right? It's a big maintenance overhead. For legacy reasons, they had it. And they want to get rid of that and come to a single marketing site, which is backed by content which is aggregated from different backend systems, product specifications and all that, right? So we were creating the marketing site and the content aggregation platform for them, essentially, right? And but it's very similar to any other project in the sense that we had your web layer, which is the web presentation layer, and we used Scala and we used the Play framework to build the web layer, and we had an API layer which was also in Scala and Play framework. The API layer actually served content to the web layer and also did the aggregation of content from all the different backend systems that we had. So what does this translate into with respect to Git repositories, right? So one thing that we wanted to do was from the very beginning, we wanted to take care that we are supporting continuous delivery. We in fact had continuous delivery stories slotted into our vault so that could be prioritized by the business. So from the very beginning, we had a decision that we're going to have separate repositories for each individual component. So we had a separate repository for the web app. We had separate repository for the services, which is the content API and the content aggregator. We had separate repository for the UI modules because the UI modules was going to be worked on by a different team, and it was a very dynamic thing where they could launch any kind of UI modules at any point in time, even after the